different solution for if we're going to expand that out across the rest of the API.
Yeah, I
am curious if you have something similar to the you find overriding in Python, so NumPy for array API. So for example, if you want to dispatch a specific function like sine or square root, something like that, in Python you can overload the new function, right?
Yes.
And you can dispatch depending on the parameter that you are passing. If it is an array, you can go in one direction.
So I think
we are doing that for BLOS too. I am curious, but only for NumPy. Okay.
Yeah.
I am curious if array API has some.
So array API, in array API you can define your own sign function, right? And I guess you have in BLAST you have a BLAST.sign function,
Yes.
right? The array API from an implementation point of view is focused on libraries like SciPy because you have this XP get XP and then you use that namespace. So if you implement the array let me open a terminal maybe and just. So basically, in practice, I think right now you use array API compat, but in principle, what you will do is you call this array namespace function on the NumPy, and it returns just NumPy. In the case of NumPy. So for BLAST, you would have to add this array namespace function, and then that's the entry point. And that doesn't happen on every call like arrayUfunc, but it happens for SciPy, it happens at the place that matters, basically.
And yeah, for BLOSC, we could also, in array API compat, implement the helpers. So something like SciPy can use isBLOSCArray, maybe we don't want to do any delegation right now, but in our tests, we can also, if there's some special case, we can then start using that in our tests. Okay. Maybe add that to our CI as well.
Great.
Thank you. So that's the way to do it in array API is that you add this namespace function. Right?
Yeah, and I guess in the NumPy NEPs, there's some discussion about like superseding previous NEPs on that like arrayUfunc.
Yeah, there's NEP 37, which basically is the point that was taken by array API and then made a bit less powerful, but I guess powerful enough. That's where the discussion came from to solve it this way, I guess, from NEP 37. Yeah, but I guess maybe the most one curiosity is what do we need to improve in array API to help adoption? What's the sticking points right now for or are there any big sticking points we should be discussing for scikit-learn, for other libraries that are curious of adopting?
So for scikit-learn, I think so we also have quite a bunch of citing code, and for those estimators, we do not have a generic pure Python, pure NumPy alternative. So we also have to make the decision: should we accept array API inputs and convert to NumPy and then convert back to the original input just to be nice and to be uniform in the library, or do we want to implement a generic version that's going to be slow with NumPy, but is not going to be used with NumPy, but maybe for others that have a compiler, maybe that might be helpful, but we don't know. Those are the decisions to make. Maybe sometimes a generic array version might be useful, but they have no idea if we don't spend the effort to check whether it's useful or not. Because implementing new stuff that is not going to be fast for anybody is pointless. So
really not implemented error would be better.
If we are there, I can just show what I'm thinking with Spatch, which I don't think is necessarily what we should be doing, but just as a starting point, maybe two things. And then and on Friday maybe we can be hacking a bit on these things.
Mm-hmm.
So Spatch, where did I put my things? I think it just closed it. No, this is not it. Sorry. Oh, there it is. Yeah. So anyway, this type of dispatching with the array. Yeah. So what we need is type dispatching only. And in Spatch, there was always with UArray, there was always this discussion that you have two types of dispatching. At least that's how I see it. One is you see the type that comes in, and the other thing is the user chooses, I want to make it faster with something. But for Array API, we actually only need the first one. We only need this to make this type faster. But in Spatch, I also wanted to look at the things to make at the second one. And the idea was with Array Mesh to take bit what NetworkX is doing, but convert it so that it works for things like scikit-image, scikit-learn, hopefully. For scikit-learn, we have to still figure out because you dispatch once for the estimator object, and then you keep doing it. So there is this extra step involved. And I always care about it being fast. I guess nobody else might be caring about it, but I really care about it. So Spatch is not written in C, but I could make it in C, and I could make it very fast. That is the important part about it. User API. This is the idea that I had. For now, is mostly we want implicit dispatching, right? User passes in CuPy array, they get the CuPy backend. But I also added this with backend options basically, and then you can prioritize a certain backend, whatever name that is. And then this is the other one, the weird one that I feel this was discussed, so I thought let's do it, and I decided this is the way to do it. If you really want to convince that use CuPy, even though the input might not even be CuPy, then you can use this right now, which is actually useful for creation functions. You need a way to do creation functions eventually at some places possibly, but it's also a bit unsafe because you might reach into a library and change behavior inside SciPy that might not expect it to change. So it's a bit of, that's why this is there, but you know. And of course we can always extend that. We can, there's end variable to change the priority of things. For adopting libraries, I want it to be very simple and just be, you create a system, backend system, you expose these options however you like, and then you just have to add a decorator. Right now the decorator takes the argument here, or it can take a caller that selects which arguments to dispatch for, or you can just dispatch on all arguments, and we can improve that. I was thinking we should use type annotations. Every argument that is annotated as an array is automatically used for dispatching. There are a lot of ways we can expand that. I think the idea is just to get started, have something to experiment with. And for the backend author, I don't know. I feel NetworkX is great in that sense that they use an entry point which allows you to have documentation so that the backend can automatically show up in the documentation. Can attach things. It also allows you to have introspection. You know all the backends ahead of time. And I like this. In the way that it currently works is basically you have this, you say which types you want to dispatch for, and Array API does not allow this. Array API is one type in, one type out. But NumPy and a lot of other things allow that you could say, for example, have a Dask array and a CuPy array, and Dask knows how to handle CuPy. I don't know, maybe we don't need this, and maybe we should actually write dispatching specific for Array API, which uses the get namespace functions, uses the name of that namespace to decide where to dispatch to. That might be from an Array API perspective, actually might be the best thing to do.
It would already be useful, and then you can make sure it works for that before you generalize out to other things.
Yeah, we would just basically, instead of having this definition of a type, we would just define the type based on the Array API namespace name.
It's all implicit, yeah.
Yeah, and then you do only the implicit part. You just ignore the rest of that. I think that might be the way to go for Array API, just to keep things simple.
Especially for replacing what's in SciPy right now.
Yeah, exactly. You could just use Spatch and just not expose any of it, right? But
True.
So that's the idea for the user. This is and then you have for the action implementation, you decorate it, and this would be to generate the entry point. This is passed, otherwise you don't really need it. and then you define the function, and I pass in an extra context to get some more information about how to use it. Network accesses should run context, which allows you to say, oh, I don't support this argument, for example, and then you raise an error. There are a couple of other things to discuss or open issues for, I suppose. For example, we could say that the library should define the default arguments, and you should not be able to replace the default arguments. There are a lot of little things. Anyway, yeah, that's the thing.
So how would you handle the negotiation? Like, for instance, if you have one backend implementation that implements one function for some parameter values but not for others. For instance, scikit-learn, we might have estimators that have different solvers, and some GPU implementation might providing one solver behavior, but cannot support all of them, or some hyperparameters are not supported, or
the way I sort it in Spatch right now is that the first step is you look at the types, and you throw away. You can quickly throw away all the things that you can't support.
yeah.
So anything that isn't type matching, you don't have to look at. But then you might have multiple that actually type match. And then you try to sort them, and the sorting, the backend has influence on the sorting, or the user has to do it with the context manager. And then you basically just ask everyone, and if the short run says yes, then you do it. If not, then not, and then you continue. So I think you could try to push some of this. Like if you have a specific method, you could try to push up for speed. But I don't know. I really care about this types being fast, because I don't want you to have to support Dask, compile, torch, JAX, and load everything, and then every time you do something with NumPy, ask 4 backends before you do NumPy. But after that, I suspect it's fine if we don't optimize it too much. But I guess we also could optimize it.
And is the backend registration user specified? Like you have as a user to explicitly enable the backends, or
so
using a context manager?
Right. My thought is that's one of the advantages of entry points, right? The user doesn't have to enable it explicitly. But if you have a backend, and then that's, I think, documentation, honestly. If you have a backend that wants to replace a high precision algorithm with a low precision algorithm, that should not automatically be on just because it's installed. And then that's why I added this explicit here. The backend has to say require opt-in equals true or false. Because I think that the backend author should think about this at least.
So it's the backend author's decision. So
it's the backend author's decision. Yeah.
That's.
You can. I don't know. I'm hoping that we can say we are all grown-ups and we can agree on it.
Yeah.
If that's not the case, I suppose. I mean, at some point you could say you don't load back entry points blindly. All the entry points that are there, you only allow a certain set of entry points. That's the worst case. But I think that's a lose-lose situation, because then you have to do all maintenance.
I think the best approach would be, okay, if there is some detail that is not supported by default, but some backend told, hey, I support this, it might be loaded. By other situation should not require user action, because otherwise it will be something. It's still, even if both are providing high precision, the floats calculation are not fully specified, and both it might happen that two different hardware produce slightly different results. So it's better to not, I move from one activate different environment and go to different results only because something is installed.
Yeah.
It still will be a problem in situation when two backends told, I support these ones, but it's still better than activating, going through entry points and activate random one, which is lastest listed in the entry points list.
Right.
I wonder whether we could have runtime warning and things like this to make it very visible to users that yes, this is not using the default implementation because you have this installed. Make sure this is what you want, but then I don't know, people ignore warnings.
So one thing I have is, I guess I forgot to put it. I have it that if you can trace, you can use this with backend options. Right now, I have it. I don't know, doesn't matter. You can use with backend options from Spatch, provided by Spatch, basically this thing. you can use to trace what calls actually happened, which backends was used. And I think you can expand that. Yeah, I don't really believe in warnings either, because I think it's just either they are ignored or they are noisy.
Too noisy.
If in practice you already have the problem, right? If you use CuPy or JAX, things might be slightly less precise already. So I think for some inputs, the user should just expect it. It's more the problem. If you use CuPy, you should expect things to be slightly different.
Also, like for instance, you might have a PyTorch input that is on a CUDA GPU, and you could have in the library, for instance, a generator API implementation that accepts this input, but maybe QML as a data implementation and no copy implementation for this kind of input. So you might still want to allow the users to have a control on this. And
so I guess I forgot to put it here, but my view on this is a little bit that QSIM should, based on your guidance, should basically say we don't use QSIM has two modes, right? If a CuPy array comes in, I guess you don't do anything for CuPy array. Maybe you don't have an implementation; it can just do its thing. But if you have a NumPy array that comes in, but you still want to use QSIM, then you would change the precision a lot, and the user. So in that case, I think what the user should have to write with backend opt. I just write it like this, but with backend opt prioritize QSIM, and then they know explicitly that it's going on. Or I suppose I also allow with backend ops that enable globally right now. I think I'm not sure what it's called. Or an environment variable. There could be many ways to set this config, but it would be QSIM's job to say, yeah, I don't kick in unless the user said so, and it's your guidance that tells QSIM to do it.
Or maybe there could be like some kind of testing guarantees, like if your backend passes the originals library test with whatever input types and the type that we.
How to check this? Because the tests are running on CI and you cannot just import run everything.
Someone makes a new test and suddenly your reproducer doesn't work anymore.
If you do that, you come to the point where by default you would only use load entry points that are blessed by scikit-learn, I guess. The other thing, of course, is you could have NetworkX does it. It has a test suite, and if the backend passes that test suite, it ends up in the official documentation. But of course, you can just write a backend that does not pass the test suite. So yeah.
And also, what would be the default priority? Like if
it's complicated.
Yeah.
In Spatch, I thought, well, I'm Spatch, I'm a small library, I can do a bit of extra work. You can try to figure out, so for type dispatching, there are clear rules, like subclass before superclass and stuff, right? So based on the types, I can figure out an order often. If I cannot right now, what we added is that the backend can say, I am higher priority or I am lower priority than this other backend name. And maybe we have to refine that a little bit. I don't think it's gonna always work, which is why I added this explicit that the backend can say, I know this backend and I definitely want to be higher priority. And generally, the default backend should be a relatively high priority, I think, always. Like if you say, scikit-learn works with NumPy arrays usually, you should always be the one that is called by NumPy arrays unless someone is very brutal about overriding that. I don't really want to disallow it, but I think it would be
someone, the backend developer or the user?
Backend developer. Yeah. If the backend developer overrides the priority over the QSIM, I think they would be. It would just be bad actor in the community.
So I think we should allow that.
We could really explicitly forbid it. The other thing is, of course, you could block list, like do a patch release that block lists that backend completely and never loads it.
That's also an option.
I'm kind of hoping that we can say it's gonna be fine, but if we have to, we'll just block list and escalate.
from my experience from Napari and our experience with people writing the plugins, it is wrong assumption. You should go in the direction like, okay, if you have QPy, the QPy should define which package is default. For example, if they ship their own, it is just, okay, we see there is entry point in QPy for this one, and we believe that if we get QPy RI, we use the QPy one. If, for example, they would like to split to the separate package, it should be something, hey, we don't provide backend, but if this package is installed, it is the backend that we believe, but don't allow random person to just override these rules by setting it really high, because someone will do this and will do explosion in the whole ecosystem. If someone would like to use backend from some random guy which is not unrelated to a given project, this should be done explicitly by a person on the beginning of the script. This person should, okay, change the backend to this, and I know what I do, not that someone is start putting this in some package and advertising it, people are installing it, and everything is crashing without proper knowledge.
But how do you enforce? I mean, cool. So the QPy, let's say scikit-learn. I guess maybe QPy is a bit different, but in general, scikit-learn would have no implementation for QPy. So that's already
no. Yes, but
API.
Well, okay, but
So for if you pass QPy input to PCA and scikit-learn, it will delegate to QPy.
so so what you're saying is that we should.
if the QPy provides entry points that talking, hey, I here provide the implementation of this function, and I got QPy RI, I should definitely go to the QPy implementation.
Right, but that means that scikit-learn needs to say this is the official one for QPy, and that should be.
No, the QPy declare, hey, I implement this function for QPy RIs, and scikit-learn see, okay, I get QPy RIs, and I don't get my implementation from QPy RIs, so I use this one which is provided by QPy, not by some random.
But surely, like, the QPy developers can't maintain like a full list of every single library, like, because then now the QPy, like, would this be maintained in the QPy repo or like somewhere separately? Like, I don't think that really works. What if I'm making a small new library and I want to make like the official backend for it? Like, the QPy developers shouldn't need to know.
Yes, I think for the reproducibility, the QPy, either QPy or scikit-learn developers should know about this and put it as okay recognized. Otherwise, you will have a problem with reproducibility.
Yeah, I mean, I see how it would work if the scikit-learn repo itself maintains like this is the official backend for this type, but.
And so I feel at that point we get to the stage where only officially blessed types backends are automatically loaded, and all others are not maybe loaded but cannot be automatically active without user input, which is fine. Maybe that's the way to do it. I was hoping we don't have to, but
It's just like if you have the PCA estimator in scikit-learn, because it's implementing using the API, the default code without dispatching except right now. But if we add dispatching using the dispatch annotation so that we can swap out this function based on the type, maybe QML actually has a CUDA implementation that accepts QPy input but does not rely on QPy to do the computation. It's delegating to its own CUDA kernels under the hood. And so in this situation, I don't want this to be automatically dispatched to QML if the user has QML installed without knowing about it. It needs to be explicit for the user when.
I don't think it's too bad to make it explicit, because you could still have it be like a single environment variable, right? So like QML, you need to like update the docs, be like, okay, it doesn't work completely automatically, but you set this one environment variable and then it will do it.
So the type in this case is ambiguous. Like it's not enough to know which backends. You cannot guess which backend. Yeah.
That's the problem with this whole like if you have multiple backends for one type. And
it's gonna happen.
No doubt it's gonna happen. Yeah. And I don't know if we can trust QSIM to not QSIM or QML to decide our thing is so compatible that we can opt in by default, or like this I think. I don't know. To me, this is a discussion that has to come from scikit-learn.
Yeah. I mean, you'll still get users who are like not aware of which environment variables are set, but I definitely feel safer than just you have something installed that you don't even know you have installed. And
I like that you have something installed. It just works for the case where it just adds new features in a sense.
Because so if you were just going to get an error otherwise,
relatively safe. I mean, of course, it might still change things, but it's relatively safer.
Yeah, that sounds fine.
And especially on HPC cluster, people sometimes they do not control the libraries that are installed. And so if a library is installed for some other use, but they don't want it for their script to be enabled.
No doubt that anything that is not, in a sense, blessed by the library and got opted by the library should not be automatically enabled. And the question is
that it's not necessarily the library that should be blessed. It's more like giving user control and
yes.
So and not be too magic with a behavior change.
I mean, the worst user experience that you change an environment of like the library and present or present for some reason, and then you don't get the same performance, same results because others put something.
So I mean, for me, I don't want to run into circles too much. For me, my takeaway is that I mean, we also have the thing for dispatching that we should probably do something more array API specific, and maybe just types. Do you care about having this allowing QML to replace the PCA implementation as such? For scikit-learn.
If the user opts in.
If the user opts in on the thing and says use QML over default in whatever way, do you want this to be possible, or do you just?
Ideally, I would rather not have to maintain a list of known backends in the scikit-learn code base. I would just declare that this is an entry point. People can register to it.
Yeah, I don't think you would have to maintain that list.
When it's ambiguous, should stick to the scikit-learn implementation as the default one if scikit-learn accepts for this type.
Yeah.
But then if the user wants to override this default type-based negotiation, they have control to enable something alternative. And in cases where there is no ambiguity, then in this case it dispatches automatically to QML. Why not? Based on
okay, right now it's patched. The effective way would have been that your generic solution is this is an array API object, because array API object is a very abstract concept.
Yeah.
I would actually prefer the QSIM implementation, because it will say I work with QPy arrays, and that is more specific than yours. So I would do it this way. But of course we can change that. We can allow you to modify that.
Yeah. Do you want like a new concept of like things that are provided by the library itself and then external things, or do you have that?
I think there's always a concept that what is provided by the library itself is more important than the other ones.
There could be also the switch that, user on the beginning told, hey, I prefer to use more specific bucket if available, but he needs to tell this explicitly. That, if there is no blast, but there is a QPy or something like this backend, I explicitly want you to try to do this. I know what I do.
I mean, what I could say is, for example, what I could imagine.
In the context of this what we know, I started, because this is, you saw the entry points as a Python files. I suggest to think about using some Tom or YAML file as entry points for such a thing, because it is not it might really easily happen that some project will provide entry points that import became a painful and long. And if you provide just the text file to parse, it's
but how do you entry points can be tunneled?
Yes, it can be any file. Entry points, it's not only here is the path to the file.
Yeah, I was not aware of that.
We use YAML and Tom as to plug in.
That is a very good.
And this is the statical and parsing it's really fast.
Right.
So
Yeah, that
we-
sounds
Because
better.
I mean this is basically all strings for exactly the
It's just
reason.
YAML,
But
right?
of course this is just YAML.
Yeah.
Yes, and changing to young DOM, etc. I will just guarantee that no one would do at the beginning stupid half-hour import.
Yes, agreed. I mean that is the whole point. Why is everything strings? Is I don't want any import to happen.
Yeah.
There is one small exception, and that is if you have a complicated abstract type, you need Python code to write like an is subclass. Done.
But it still would be okay if the DOM defined if we have here
Sure.
metadata, but if you need to get it, import this.
Yeah, I mean the way I do it right now is this. Like I say this is basically add my array API, like array API like. That is the way I kind of say how to define it. And if I see this, I see okay, yeah, I suppose I have to import this one because otherwise it doesn't work. But that's a good point, Tom. Thanks.
What about backward compatibility? Like for those entry points, there would be some, not necessarily, I don't know, for maybe for SciPy it's only public functions, so they are stable. But for scikit-learn, the entry point might be inside an estimator object
Yeah.
to decorate a function and not a class, because decorating, swapping out a full class, I don't know. Maybe it's a good idea, it gives more control to backend developers, but then you have to re-implement everything and make sure that you're consistent.
No, you may just inherit from the scikit-learn class and overwrite only this single method.
Yes, but then if you do that, you depend on
You need
private
to-
API.
Yeah, you need to just I think it's easiest. I think I kind of agree. It's probably easiest if you have internal functions that maybe return an object that describes all
when
the
you do
other.
that, it means that for all scikit-learn classes, we need to carefully define what is the entry point, what is meaningful, and
Yeah.
sometimes later, but we chose originally to only make this part pluggable, but now it makes sense to also have this other part of the estimator that is pluggable.
And then that's effectively public API. Like, yeah.
I mean,
And so it means that we need to have those decisions on what is the backend API everywhere in scikit-learn, whereas if you say, oh, you can swap a full estimator class, then we don't have to have these decisions. And the dispatchability adoption in scikit-learn will be much faster to implement. But,
it's much easier, yeah.
yeah.
But what if you have basically one entry point function for each estimator, which is called, I guess, usually a fit, and that returns you it returns an internal.
It's not just fit because for decision tree model, for instance, the internal data structure that results for fit and you can use for prediction or transformation might be a C++ class. And
but you dispatch on fit mostly, right? Like you look,
Yeah.
you dispatch based on
Yeah.
after fitting, the dispatching is kind of a.
But then the state of the estimator that you will reuse at prediction time, you don't necessarily want to convert it back to a scikit-learn data structure, a Cython data structure. Most of the time they are numpy arrays, sometimes they are structured arrays.
Right.
But I don't know.
It's complicated. Yeah, I think it's just slightly more.
Yes.
This additional step that we have to figure out.
Yeah, a lot easier for SciPy if it's just
For
each
functions-
public function. Then
Functions
you'll have-
without states is much easier.
I mean, you can.
Yeah.
We could also have like the dispatch state. What is the state of dispatching after the fit function or inside the fit function? You could store that, but I'm not even sure that it's very.
This is what we
That
did.
it really helps with this problem all that much.
We did that in the original. We have this engine API prototype, which is based on entry points and stuff like that. And we store the dispatched engine as a private attribute on the class.
Yeah.
And then at predict time, you have to reuse that and you do not negotiate again. You have to reuse that.
Yeah. So I mean that's something I support here also, that you can basically store at least approximately the dispatch state at that point, and I could make it even more concrete to store that. That you always end up at the same place.
So how would this work across the version? Because let's say in one version you have one behavior, then there was something wrong with it, next version gets fixed, but then you have the backend. I would say you want to make the backend compatible with different versions. So how do you know which behavior it is to follow? For example,
I mean, the backend always could check the version of the runtime library, and that's like AstroPy and NumPy. That's actually working out fine. But I guess for scikit-learn, for other libraries that move faster, it might be.
But do you force the backend to like make a new release, and they can't say, "Oh, I'm compatible with less than 5"?
Well, AstroPy, I mean, basically, if you keep, if there's a new NumPy release, a few corner cases might stop working for a while until it's fixed, I guess. That's
But they don't need to make a new release. It will still work.
Well, no, but everything that didn't change will keep working the same way.
Okay.
I suppose for us, you could say that you could version this function, right? I suppose we could add a version there. So
you basically leave it up to the backend developers how much checking they want to do, rather than forcing them to define. I know that I'm compatible with these versions.
But it's more like if we allow dispatching on private functions. And we need to refactor like the list of arguments. Like for instance, one argument is split into or the opposite. Then we will break all the backends. So maybe we could introduce a new entry point with a new name.
You can always do that. You can always change the entry point. You can also introduce a new, like just rename the function, right? Then the old one will turn the old version. The new one just ignores that function, right?
Can we version the entry points?
You could.
So if we expect it to keep working, then
we could also add a version here in principle. I'm just not sure what that is pragmatic to do.
So just say you should bump the version anytime you change the parameters or intended behavior.
We could also force a tested with or something, and then give a warning whenever you load the entry point on a version that is incompatible, I suppose.
Yeah.
Warnings are
back to warnings.
Suddenly warnings are great.
And then nobody takes notice.
I don't know. This is very tricky. I think I would like to start with I guess SciPy, where you have this function and you don't have this class case, but
Is the scikit image dispatch mechanism that is already implemented based on Spatch?
No. I'm not sure. Scikit image has its own. I would like to replace it with Spatch, honestly.
Okay.
I think. I think. I don't know how the scikit image people think. Spatch just does a bit more right now than this. And if we can agree on how it looks for the user and how the entry point looks, at least approximately, then I think it makes sense to try to. So if we can agree on sorry, this is not user API. So whatever, I think I have. Let's just go to the actual documentation. If we decide that how users work with this thing with like type equals or prioritize equals, if we can agree on these backend opts and how the user sees it and how the user has environment variables, then I feel we can just and scikit image does not have to use Spatch as an import. It could also just render the whole thing, right?
So when you say prioritize QSIM, if you pass an NumPy as an input, it will automatically do the conversion?
It's possible. It's Kusen decisions Kusen could decide to do it, yes.
And it would have NumPy in the secondary types.
Yes,
right?
No, actually no, because the primary type is a type that has to be there to dispatch to. Kusen would have to put it into primary and secondary type. And if it is, normally it would happen after the normal backend because it supports more, like Spatch will sort it afterwards. But if you do prioritize, it will sort it first, and then Kusen has to see, based on the context that I passed in right now, that it is prioritized, because otherwise you would need two plugins to do the same thing. One for NumPy arrays, Kusen NumPy, and one for Kusen Kusen.
So what is the situation where you only have secondary types and you don't have it in?
That is impossible.
It's impossible.
Because for primary type there has to be a primary type for you to dispatch to that plugin.
So what is purpose of secondary type?
The idea is that in our type of world with array API, you have multiple array arguments, and they are all the same. Order doesn't matter. And primary means if you find that type, that backend can be chosen. Secondary type means I will also accept these, but if I find that type, I will not dispatch to you. So for example, CuPy might accept, the CuPy backend might accept NumPy arrays, but the CuPy backend will never be chosen for only NumPy inputs. So that's a secondary.
Okay, because I expect that it could be used also in the way, okay, I just told, I know that it might be NumPy array, and you it is secondary. So, okay, secondary means that there's additional step of conversion required. But, okay, hey, I prefer you to do this conversion and run it.
Yeah, yeah, I guess that's just not what it is right now. It would be a primary type, but with this require opt-in. So if I write a custom backend or a CUDA backend or like a parallel backend for NumPy arrays, I would say require opt-in equals true, and primary type is NumPy, and it's not used normally, but then if the user opts in, it's going to be used. That would be the idea.
SK image.
What? Skip it. Anyway, yeah. How long time do we have actually? Because
Minus 15 minutes.
minus 15 minutes. Oh yeah, approximately.
Just in time for SK image.
We got it. I know that's SK image at level 20 the patch already.
Yeah, okay.
You matched. Yeah, I don't know. I mean, as I said, I feel like this is a discussion basis in a sense, and for Scikit, for SciPy, I think we should probably write our own thing, at least for now.
Yeah, I mean, even the internal, like each implementation for different SciPy submodules is not quite the same right now.
Right,
So even if we could just get them all using Spatch, it would be a
We
nice...
could also just try using Spatch and see how far it goes on.
Yeah, yeah.
That might be the
I
way to
think
go.
we should.
And I hope you did talk about this already, but I think is there something? There was some part joke, some part serious mentioned about library using its own dispatching backend to, for example, I don't know, provide different versions of a function or backend. Is that something you see as like
So you mean like SciPy through a function could have like a separate repo that makes like a special backend for it, and then
like that, yeah.
a SciPy user can say, I want the implementation that lives in this repo or the one that lives in this repo.
I mean, I feel like it's totally sensible to do, honestly.
Yeah, I mean, that's kind of
because-
covered already. It just means that SciPy becomes both the backend author and
Yeah.
the
I
library
I
author.
think that makes a lot of sense, but especially in the case of SciPy, where you have where it makes maybe sense to have Torch and Jax backends inside SciPy because you want to specialize them.
Yeah. And then you can
Um,
ship these additional backends with like extras on PyPI or like a different conda package.
Yeah.
Yeah, no.
And that would be a way for
Yeah.
for their own library to take some control about and use the function.
And then you just use Spatch for everything, and the main repo is like just the API.
Exactly.
All the implementations are in a different repo.
That's the idea.
Yeah.
No, but yeah, I think that makes sense.
Anything else?
In case there is a conflict of default priority, what would be the default priority? Is it a lexicographic order?
Right now, it's if it's built in, it's before a thing. If it's types, it's built in. It's then then what the backend chooses, and then lexicographic. Yeah. But I mean, we can do anything. I don't really care too much. I think you need some flexibility in the priorities, and then there's the question of how much the library or Scikit learns should control it.
So the prioritize here, you want to prioritize a single backend.
But you could also have a list there.
Yeah, but if it's the user, if the user prioritizing, then there is no problem. The problem is that if you install stuff and you have new.
Yeah, I don't. I mean, I think that problem just exists in a sense. It should not like.
Because, for instance, if it was the case of SciPy that has sub-projects or sub-repo, SciPy Jax or something that are official backends for SciPy, maybe you want them to be higher priority by that Spatch recognizes that they are higher priority than some random stuff.
Yeah, I mean, right now I can do that if it's integrated into the library. if you load those entry points earlier, but I think
But
it's not. It would be
if they're
easy
two
to.
separate.
Well, but I mean that's easy to implement. It's just one more
Sure.
option to say like these are blessed backends in a sense, and those are.
But then where maintains that the main
That's why
SciPy
that needs
repo has to have
that
the
needs
list.
the
of-
main repo would have to have a list of blessed backends in a sense.
Okay, yeah.
Yeah.
Can I ask what the story is around a backend only partially supporting some parts of the API, and then you're, for example, operating with the CubePy in the area, which is on the GPU? What happens if the function doesn't support it? Is there a way to automatically coerce it back into another array, or is there some kind of default
Yeah,
array type?
right.
concept?
NetworkX has this concept of conversion, and I always thought it's a bit complicated and weedy, and I decided to. I mean, Spatch does not have it, and I would kind of prefer to stay that way at least for now.
I mean, the SciPy implementations right now, yeah, they fall back to just convert to NumPy.
You can also.
And then we keep track of the input namespace and rewrap it at the end if there's no other implementation.
I can see that you could, for example, within, I mean, also within Skimmage, right? You could say that the Skimmage version says if it doesn't get NumPy, it does some special slow fallback path, or you have a backend within Skimmage that deals with this.
So what would currently happen with this implementation? Will it fail?
It will do whatever. Yeah, it will fall back to whatever you say the fallback is, which
Okay,
is, and
so
it will
that's-
probably just fail. Yeah.
Okay.
And I suppose you might want to add this one step of giving a user warning or so if you really want to expand to so many tabs.
So the use case is only really for if the part of the API you're using is completely implemented by the backend. If there's one function in there, it's a bit.
Yeah.
Is
I
it
mean,
transparent?
you can ask each function, and I mean, of course, we have to improve that, but you can. We can attach whatever information you want, right, to this function. And for example, we can extend the documentation, and we can make it introspectable that you can see which backend implements which functions, or which, the other way around. If you ask a function which backends exist for it.
Would the user notice that this falling back is happening? Is there a log message, a warning phrase?
Well, I have tracing. I did not add warnings to Spatch because I think a lot of warnings are also super annoying on
The
this.
tracing, I think, is useful.
Tracing
Kind of
has to be enabled, of course.
I don't want to grill you
so
because we
what I
talked
can
about these problems as well, and that was the hard stuff to figure out. Actually, what is the use case for the whole spreadsheet stuff? Do you want it to just enable it and run? Do you want users to be aware of there being a missing API implementation?
I mean, so I'm hoping that we don't have to solve that on a generic case, in the sense that we have a fallback and we know that the fallback is called. And right now, fallback and default implementation is the same thing, but I can pass in that information, and then you can choose to give a warning when the fallback is chosen. And maybe we can add that to Spatch, or maybe we do it inside the library. But I feel like, I kind of think if we add at the fallback, we should have a hook, or we already have kind of a hook that you can choose to give a warning.
Mm-hmm.
Okay.
And I guess I still have to add that, but it's not a problem to add.
Yeah, it might be fine, like it totally depends on the use case and backends involved. If it is a huge cost and you need to alert the user about, hey, you're doing the slow fallback, or if it's not, I don't care.
Yeah, agree. Should make some notes. Yeah, I don't know. I guess we will hack on SciPy on Friday probably.
Sounds good.
Hopefully. But if anyone is curious,
Shame Evgeny isn't here.
just to try. Yeah, it's really important.
Because he wrote the signal and anti-image stuff, so it'd be nice to.
Yeah, maybe we could try to prototype Spatch integration for the PCA class in scikit-learn for QML, and there's also one by Intel. I think scikit-learn Intel X, there are alternative stuff. So
Sounds, yeah, I mean, I would be very happy to just try it out, and if Spatch is just the basis for trying it out, and at the end we do something else, it's also great.
I don't know if we try to both,
Don't merge either. Yeah.
The reason why I hope that that we use Spatch or something like it as a library is that at one point I would like to move things to C and make it very fast. But and that I think is something not everybody can or wants to do.
Rust nowadays.
Oh yeah, you're right. You should use Rust.
Spatch backend. Yeah. But yeah, I definitely like the idea of a library. Having like every single library have some like custom dispatching going on just seems like a complete mess. Yeah.
And yeah, from a user point of view, working with the ecosystem with
Everything has different parameter names. Yeah, it's a nightmare.
Yeah, I mean, it's, in a sense, that's actually the most important thing, that you just agree on a user API, on a user experience.
Yeah.
And how the implementation is in the end doesn't matter too much.
Sure.
I don't know, we have been very long, and I don't know when the next session and break starts and whatnot, so
I think it's
Not right.
so we should.
Right now.
I mean, we can talk forever here. I've learned a few things about what to look into. We should discuss more. Yes. I have to see more about this. No. I probably wanted to see about the second level of the class. It's in pretty good shape.
I'm still emphasizing
I'm hoping that you kind of go into the
Yeah, it's usually farming as well.
Unlike that, you actually have
the initialization mechanism plus solve function that is like the field method has actually two components, two solvers basically. And then
one is the data
oh yeah, and on that also is that on GPUs,
So the other way I could see it is that every method on the page is a dispatchable, but as soon as one of them is dispatched, we store that state and keep dispatching to exactly the same thing. So yeah, exactly. And so basically